Hello, welcome to my YouTube channel. We are discussing a new topic today, model verification. If you're a modeling engineer in a foundry or design house, you will know that in addition to the model development part, model QA is also a big work. For foundry guys, before the model release, they need to check the model quality, make sure the model qualifies certain criteria. On design house side, when they receive the model library from Foundry, they also need to check the quality of the model. Model QA is also an important part in design house. The QA process of the whole library is complicated. The library usually includes lots of devices and multiple corners, and there's lots of items need to check, like accuracy, model train, parameter range, corner cross, corner range, etc. So if you do the QA work manually, it takes a lot of time. Since the QA includes lots of repeating, simulation, and plotting work, if we can do it through a tool, it will make the work much easier. MQA is an industry standard model QA tool. Now let's look at MQA together. MQA framework is very simple. First of all, we need to call simulator to run simulations. MQA supports most of the commercial simulators like ADS, HSpice, Spectre. The input files includes only the model library file, MQA rule file, and depends on if you need to run accuracy check, you can include the data file or not. And the core part of the MQA is the rule file. The rule file defines how you want to qualify your model. With those input files, MQA can generate an net list to run simulations. At the end, you can show your readout on MQA manually. And after you checked everything, you can export the readout to a report. The report format can be Word, Excel, PowerPoint, PDF, HTML files. Here's the brief overview of MQA capability. First is measurement QA. You can use MQA to check your measurement data quality. Second, you can do accuracy check by overlay the data and simulation values on the same plot to check the fitting accuracy. It can be the curve data or WAT data or the spec. The third one is some basic check for single model like convergency, robustness, and some physical behavior like parameter range, bin continuity, chain check, and also the effects like special flag, effects behavior. The first one, you can do model comparison inside MQA, like different version model compare the current version with previous version to see what is changed in the model. You can also compare model with different simulator versions, like between HSpice and Spectre. And the compare contents can be basic IVCV behavior or the target consistency. You can also run corner QA inside MQA, like the corner chain check, corner compare, corner versus spec, and then run the corner box. MQA supports statistical QA as well. You can create a histogram plots, scattering plots. You can also overlay different corners versus the MC plots. The most complicated one, for example, this one, you can overlay the 5 corner box plus the Monte Carlo plus the mismatch. From the above, we know that MQA is a model verification and documentation tool. You can use it to verify models and libraries with standard routine, and you can also compare all types of models. You can compare between different types of models, and you can use it as a reporting tool to generate documents. And then you can share the results across different teams to review the model. Okay, that's a very general introduction part. In the later videos, we'll have some examples. Thank you.